In this video, we're going to review some of the basics of the real number system. It is the system of numbers that we use in classes like this. There are numbers that are not included in the system, and in fact we will see a little bit of things like imaginary numbers in this class, but the real numbers is kind of the most common system of numbers in all the math classes you probably be taking. Now, how do we work our way up to the real numbers? We start with something called either the counting numbers or the natural numbers, depending on who you ask. They're all the numbers 1, 2, 3, 4, 5, and so on here. They're the ones you first learn as a child growing up. You learn how to count things with them. That's why we call them the counting numbers. They were called the natural numbers by some philosophers. They said that's what is given to us by nature, and anything else is derived by man. That was the idea, at least. Regardless, I do want to point out this little curly bracket system here. This is something called set notation. It's a way to describe taking a bunch of separate things and talking about them as one. As an example of this, you are all individual students, but I can talk about this class by grouping them all together here. That would be a set. So again, set is just a way to group a bunch of things together, and we use these curly brackets here. There are a few different ways that we could use them. This first one, where I just list the individual numbers inside of it with ... that's called roster notation, as in you are listing the roster of the people in the set. So if I were to write out all of your names in the class and put curly brackets around it, that would be the roster notation for this class. Anyways, after counting numbers, we get to integers, which is just take those counting numbers and throw in negative versions and 0. That allows us to have both gains and losses and things like that. So it kind of completes our whole number system here in order to get things we need. Those you learn about later in your life. You start learning about negative numbers. Definitely have had a lot of students in the past complain about the rules for negative numbers, but it's just one of those things you have to kind of get used to and how to handle them. Next up, we call something that are rational numbers. And rational numbers, a lot of times people learn about it as decimal numbers that either repeat or terminate. So for example, 5.29, that would be a rational number. That is a decimal that ends at some point. Another example would be something like 0.3 repeating, or 33 1/3%. That would be a repeating decimal. It's also a rational number. Now, if you were to go ahead and look in a math textbook for the definition of rational number, they would write it as follows here. They would say the rational numbers are the set of all a over b, such that a and b are integers. Basically, rational numbers are all the numbers that are fractions of these two integers here, positive or negative. And when you describe what it is and then give a rule for it, this is called set builder notation. Regardless, though, rational numbers are the decimals that either stop or go on forever. These are the numbers that you deal with most often. Right? Generally, you have a decimal that's going to stop. Even if it wouldn't stop normally, most people will then round numbers for applications. And rounding numbers means it's going to stop anyways, so you have a rational number. On the other hand, there are things such as irrational numbers. So irrational numbers would be ones that do not end and do not repeat. An example of an irrational number is something like the number pi. Right, you guys have seen the number pi before. It's talking about circles here. So pi if you care, it starts out, 3.14, but then it keeps going on, and it never just settles down to a repeating number here. It keeps changing as you go forever and ever. And irrational numbers, they're a little bit strange for people at first because you don't see them very often. Pi is one of the ones that you mainly use, but it turns out there are lots and lots more out there, and we will encounter them in this class. And finally, this is the whole point of all this discussion, is the real numbers are just take all of your rational and irrational and put them all together, and those become the real numbers. So basically any decimal at all, that's a real number. Okay, now, what can we do with real numbers? Well, one thing we can do is we can round. And I've definitely seen people making mistakes on rounding, so let's be very careful here. This problem says round the number 1.347 to the nearest tenth, and then it says in parentheses 1 decimal place. That's because some places you look will ask you round to the tenth. Some will specify 1 decimal place. It just depends on where you're getting the problem from. You should understand both of them. So the way this works is you identify the 1 decimal place or the tenths place. That would be the number 3 here. And then what you do is you look exactly 1 to the right of that. And if that number is 5 or more, you round up. And if that number is 4 or less, you round down. And in this case it's a 4, so I round down. And rounding down means you just drop the whole part there. The 47 just goes away. And this would be 1.3. Just to show you the example here, if this had instead been 1.357, we would have looked at our single number here. We would have looked to the right by 1 digit. We would have seen a 5 or more. We would round up to 1.4 here. I will say, I have seen in some other circumstances different rounding rules than this. I have seen in some circumstances that if the number is a 5, you do some sort of weird even odd thing to figure out rounding up or down. But I will tell you, for everything that we do in our math classes, 5 or more rounds up, 4 or less rounds down. Okay? The last thing for this video is something that really causes problems for people, and that is called the order of operations. And part of the reason for that is because people are actually taught it incorrectly. So the thing is people hear PEMDAS and they think things like you always multiply before you divide and so on, and that's just simply not how it goes. The better way is to write it like this with PE and then MD and then AS here. Because yes, you first do things that are inside of parentheses. Then you do any exponents or roots in the problem. Then you go from left to right and do all multiplying or dividing. And then finally you go left to right and do all adding or subtracting. So here's 2 examples, one easier, one harder. So this first one here, we have 4 minus 2 times 3 minus 5. Do I have any parentheses? I do. So I need to do whatever's inside the parentheses. In this case, it is 3 minus 5. So then I go ahead and do 3 minus 5. That would give me a negative 2 there. Then I write down everything else in the problem. Then I need to figure out what my next step is. I look for any exponents. Well, there's no exponents here. There's no roots here. Then I look for any multiplying or dividing. Now at first, you might say there is no multiplying or dividing, but when you have 2 numbers next to each other, separated just by parentheses, nothing else, it is by default multiplication. And I totally understand if that's annoying. People should just put the symbol they have there, but this is the way we do things in math, so it's something to get used to here. So it's really multiplying there. So we're going to go ahead and multiply, Negative 2 times negative 2 is going to become a positive 4 here. And then 4 plus 4 gets you 8, and that would be the final answer. Now for my second one, I go inside parentheses. I see two sets of parentheses, so I go left to right. In the first set of parentheses, I have 6 minus 8 is negative 2. Then in the second set, I have just 2. Well, there's in fact nothing to be done inside of there, so I just leave it alone as a 2 there. The parentheses are almost unnecessary, not important in that case, because there's nothing going on inside of them. Then the next thing I do is I look for exponents. I see 2 exponents, so I work my way left to right. 1 cubed is 1, 3 squared is 9. Copy everything else down here. Then I'm going to do multiplying and dividing left to right. Here's a multiplying. Negative 12 times negative 2 is 24. Here's a multiplying. 1 times 9 times 2 is 18. And then here's a multiplying. Negative 6 times 2 is negative 12. And then we do all of our adding and subtracting left to right. 24 plus 18 would be 42. 42 minus 12 is 30. And that would be the answer to that problem.